Welcome to Automotive Education with Emmanuel. Today we'll be talking about fuel consumption. The knowledge of the amount of fuel consumed by a motor vehicle engine in a given time is very essential when assessing the qualities of that engine. Motorists, that is drivers, normally consider fuel consumption in terms of kilometers per liter of fuel, but engine designers normally consider fuel consumption in terms of the flow rate of fuel with respect to the power that is being developed, therefore giving us the unit kilogram per kilowatt hour. And this is what is normally referred to as the specific fuel consumption. And it depends on the calorific value of the fuel. What is calorific value? Calorific value of fuel is the quantity of heat produced by its combustion at constant pressure and standard conditions, that is at 0 degrees Celsius and a pressure of 1 bar. Specific fuel consumption can be measured in terms of the power that is being developed in the engine or the power that is being recorded at the output shaft. Hence, we have what we call the indicated specific fuel consumption and brake specific fuel consumption. The indicated specific fuel consumption is the fuel consumed per hour with respect to the indicated power developed, and it will be in the unit kilogram per kilowatt hour, or sometimes represented in liters per kilowatt hour. Just like the indicated specific fuel consumption, the brake fuel consumption is also represented with respect to the brake power that is being developed. So brake specific fuel consumption is equal to the fuel consumed per hour with respect to the brake power that is being developed. The units are the same. Now, the question one may ask is, how do we measure these quantities? The fuel consumption can be measured on a test bench by allowing fuel to run through a special measuring device. Now, this can take the form of a fuel tank with fuel in it, and then they will use it to feed an engine. Let's say there's a valve here. The fuel in it, we know it to be of a known quantity in liters. So the time that it will take for the engine to finish this fuel will give us the fuel consumption, which will be in the unit of liters per unit time. Another form by which we can measure fuel consumption is by the use of flow meter. Here we can do a setup like this. Let's say this is the fuel tank with fuel in it, and then we pass it through a flow meter, which will now give it to the engine. The flow meter will now take the fuel into it. You can place a valve here, and then we'll now measure the mass flow rate through this flow meter. The mass flow rate through this flow meter, which will be as a result of the volume of fuel multiplied by the density of the fuel times 3600 to convert it to hour over the unit time that it takes for the fuel to be fully expended. This will give us the unit kilogram per hour, or liters per hour. You know, when we make the assumption that a kilogram, a liter of fuel is equal to a kilogram of fuel. Knowing the flow rate, we can hence write the brake specific fuel consumption to be equal to the flow rate of the fuel over the brake power, or write the indicated specific fuel consumption to be equal to the flow rate of the fuel over the indicated power. Now, how do we reduce fuel consumption of our vehicle? There are several ways by which we can reduce fuel consumption of our vehicle. One known way is to keep the engine at its maximum torque. by allowing the engine to rev at about 2500 rpm and 3500 rpm. In that range we have the maximum torque being recorded for the engine. So if we keep the engine to be revving at about 2500 rpm to 3500 rpm, we will attain the best fuel consumption for that engine. Another option that we have is to avoid aggressive acceleration. Yes, we need to avoid aggressive acceleration. This aggressive acceleration behavior of drivers usually leads to large instant fuel consumption, because when you depress the accelerator pedal instantly, you issue a command of high load on the engine, which also in turn allows the engine to request for the highest amount of fuel to overcome the load that it needs to overcome. To reduce fuel consumption, we can also make use of engine braking. With engine braking, what we do is that we lift our leg off the accelerator pedal. We do not brake, hence we maintain a constant speed where there is no acceleration and there is no braking. So the speed of the vehicle tends to be higher than the speed of the engine. When it happens this way, the engine's compression will now be used as a braking effect to the vehicle. So in that condition, there will be no fuel, no large amount of fuel which will be used because there is no acceleration. No large fuel supply to the engine since there is no acceleration, and then the compression effect of the engine will now be used for braking. That is all for today. I hope you've enjoyed it. Now let's recap. We started by looking at what fuel consumption is, how motorists understand fuel consumption. When I say motorists, I'm talking about drivers. Understand fuel consumption. They understand fuel consumption by the amount of fuel that is necessary to take them how much distance they want to cover. So that amount of fuel is measured in liters and the distance that they want to cover is in kilometers. So if they can cover a large distance with a little amount of fuel, then they think they have what they call a high fuel economy. If they can cover a large distance with little amount of fuel, then the fuel consumption is low, so they consider to have what they call a high fuel economy. But if they can only cover some short distance with a lot of fuel, then the fuel economy is not good, so they say they have a low fuel economy, and then they will say the fuel consumption is quite high. But when it comes to engine designers, They consider fuel consumption in terms of the amount of fuel that is being consumed and the power that that fuel that is being consumed can develop in terms of the time that the fuel has been consumed. So that is what we refer to as the specific fuel consumption, and it highly depends on the calorific value of the fuel. I went on to talk about what calorific value is, and I said the calorific value of the fuel is the quantity of heat produced by the fuel through its combustion at a constant pressure and standard conditions such as 0 degrees Celsius and a pressure of 1 bar. I mentioned that the indicated and brake specific fuel consumptions are what engine designers consider in determining what engine consumes more fuel than the other. So the brake specific fuel consumption is the fuel consumed per hour per the brake power developed, and it is measured in kilograms per kilowatt hour. The indicated specific fuel consumption is the fuel consumed per hour with respect to the indicated power that is being developed. So we also went on to talk about how we can measure the fuel consumption on a test bench. So we can do this by taking a known amount of fuel and supply it to an engine and use a stopwatch to measure the time that it will take to expend it. So the fuel consumption in this case will be in liters per unit time. Another way is to use a flow meter. Then in this case, we'll supply fuel through a flow meter and then be able to tell by direct reading the fuel consumption. So we can do it by calculating the mass flow rate of the fuel through the flow meter. When we know the volume of fuel that is being supplied and the density of the fuel and the time that it has taken for us to use the fuel, then we can calculate the mass flow rate of the fuel. Then we'll use that to calculate the brake specific fuel consumption and the indicated for specific fuel consumption. Then I also mentioned about how we can reduce fuel consumption. One way is to keep the engine at a maximum torque, that is at an RPM of 2,500 to about 3,500. Then we should also avoid aggressive acceleration. Instant acceleration creates instant load on the engine, which also requires for high amount of fuel to overcome such load. We can also use what we call engine braking, and with that we are treading at a constant speed, hence there is no acceleration. That means no fuel demand for overcoming the load conditions. Now that is all for today. I hope this helps. Hit the like button, leave your comments below, and subscribe. Thank you.